So this one is the AS Physics pop quiz, which was related to DC electricity. We have a filament lamp which is marked 12 volts and the power is 60 watts. The diameter is given 0.25 millimeter and the resistivity is there. We want to calculate the length. So the formula to calculate the formula which relate the resistance, length, and cross-sectional area. R equals rho, the resistivity, L the length, divided by A. So if we need the length, it will be RA divided by rho is equals to L. And what we need the area, cross-sectional area. The cross-sectional area will be equals to pi r square or pi d square by 4, or you can also use pi r square. But it is given in millimeter, diameter is given in millimeter, it should be in meter, the SI unit. So 3.14 times 0.25, if you want to convert the millimeter into meter, we divide by 1000 or 10 power minus 3, that will be square, and then whole is divided by 4. This will give us a cross-sectional area. So R equals rho L divided by A, or L is equals to rho A divided RA divided by rho will give us the length. That is what we need. But before finding the length, we need the cross-sectional area. As we don't have, so we can use pi r square or pi d square by 4. So when we substitute these values, we'll get the cross-sectional area as 4.9 into 10 to the power minus 8 meters square. Then how to work out the resistance? As we have in the question, we have the voltage and the power. So formula P equals V square divided by R. So if we need the resistance, so it will be V square divided by P. So voltage is 12. So 12 square divided by power, which is 60. So 12 square divided by 60, that will give us 2.40. So we have the resistance now, which is 2.4. We have the cross-sectional area, that is 4.9 into 10 to the power minus 8 meters square. And we have the resistivity, which is 5.6 into 10 to the power minus 8. So when we solve, we'll get the length of the wire, which is about 2.1 meters. So that is the length of the bulb or a filament lamp, which is having a resistance of 2.4 and the cross-sectional area of the wire is 4.8 into 10 to the power 4.9 into 10 to the power minus 8. The next question, a student has two filament lamps. Lamp A is marked 12 volt and 60 watt and lamp B is marked 12 volt and 30 watts. The student set up the circuit as shown. The student state that both lamps will operate normally. Evaluate whether the student's statement is correct. So the student state that these two lamps will have the same brightness, operate normally. But how we can compare them? First, we'll compare because they are connected in series. When they are connected in series, what is same characteristic for a series circuit? In series circuit, they have the same current. The current in the circuit throughout the circuit will be same. So if we compare their brightness, this is a power rating, like this is 60 watt, but which one produce more or which one will be brighter? If the current is same, what is the relation? That P is equals to I square R. That is a formula which relate the resistance, current, and the power. So if the current is constant, what is the relation between power and resistance? Power and resistance are directly proportional. So when we check the resistance of these two, which lamp is having a high resistance? So, and they're connected in series. So when they're connected in series, when two or more lamps are connected in series, what will happen? They will have If they have the same resistance, then the voltage will divide equally. But if they have the different resistance, then they will have the different voltage. So we have the voltage and the power for each of them. So what is the relation between the power and the resistance? Like lamp A, it's marked. So lamp A, the power is marked 60, and for lamp B, it is marked 30 watts. So as they have this same current, the potential will not divide equally in this case. Why the potential will not divide equally? Because the resistance A has a lower resistance than B. How we worked out A is having a lower resistance than B, because if you work out the resistance, P is equals to V square over R. P is equals to V square divided by R. So if I want to work out the resistance is V square over P. So if I want to find the resistance of lamp A, if you want to find the resistance of lamp A, so it will be V square over R, and resistance of lamp B will also be V square over R. So V is the V square over P, not R. So resistance is V square over P. So for lamp A, the voltage is 12. If the voltage is 12 and the power is 60, when we work out the resistance, so it will be 144 divided by 60. 100. Why we cannot use P is equals to VI? Because we don't know the. You can use that as well, but first you should find which is having a high resistance. If they were having an equal resistance, then they will have the same voltage. But first, what we are finding which component is having a high resistance by the values. So P is equals to V square over R. So R is V square over P. So 144 divided by 60. So resistance of A will be 2.4 ohm. And if you work out the resistance of B from the given value V square over P, so V is 12 square divided by P is the power 30. So this will give us 4.8. Now we have this has a resistance of 2.4 ohm and this has a resistance of 4.8. So when the two components have different resistance, so the voltage will divide unequal. When the voltage divide unequal, the one which is when the two components are connected in series, voltage will divide between them. If they have the different resistance, then the voltage will division is unequal. The one which is having a high resistance will have more voltage. So the voltage of lamp B will be more than voltage of lamp A. So if the voltage here is higher, more potential is there. So brightness of a lamp B will be greater than the brightness of lamp A. So student is stating that both lamps will operate normally. Then student statement is incorrect. Why it is incorrect? Because the resistance of lamp A from the given value, it's lower than the resistance of lamp B. So if the resistance of lamp A is lower, it means it in series, the resistance, the voltage depends on the resistance of the component. The one which is having a high resistance will have more potential across it. So as a result, A is having a low resistance, so it will have less potential. B is having high resistance, so it will have high potential. So they will not receive same 12 volts. So voltage across A will be less than 12 and voltage across B will be more than 12 because the total voltage is 24. So out of 24, 16 volts might be here and 8 volts will be here because the ratio of the resistance and the ratio of the voltage should be same in series. If they have the same ratio, like if they are equal, then the voltage divide equal 1:1 is the ratio. But here the ratio of the resistance is 1:2. So ratio of the voltage will also be 1:2 as well. If you use a formula, why we did not use this formula P is equals to VI? Because we don't know the value of the current and we don't know the value of the voltage. Is it clear, this one? So this was a pop quiz. This was a pop quiz. one which was related to DC electricity,